Good morning students. Today we are going to continue behavior of gases, remaining gas laws. In the previous session we have completed Boyle's law and Charles' law. Today we are going to cover in today's class combined gas laws and Ampton's law, Gay-Lussac's law of combining volumes, Avogadro's law and ideal gas equation. Right? Okay, let us start our class today. The first one is combined gas laws. So, what is this combined gas laws means? We have completed two gas laws. First one is Boyle's law, another one Charles' law. What we know about the Boyle's law? Boyle's law is nothing but P proportional to 1 by V. And what is Charles' law? V proportional to T. Right? So, V is directly proportional to T and P proportional to 1 by V. Based on these two equations, see P proportional to 1 by V, then we can write it as PV equals to K constant, and this one we can write V proportional to T means V by T equals to constant, right? So from this we can write PV by T equal to constant. So from this PV by T equal to constant, when you are taking a two different conditions or two different gases, then this will be P1 V1 by T1 equal to P2 V2 by T2. This is called combined gas laws, right? Okay. Now come to the application based on these combined gas laws, right? Okay, let us read what the problem is given. 150 ml of a gas at standard temperature and pressure means STP are heated to 90 degrees Celsius and allowed to expand to 233 ml. What is the resulting pressure? So first of all, let us see what is the data given in the given application. 150 ml of a gas means at V1 is given. How much? 150 ml of a gas at standard temperature and pressure. Standard temperature means at STP conditions are this. STP conditions are this. So what is the standard temperature means? 273 Kelvin, right? And what is the standard pressure? 1 atmosphere. And he is asking, are heated, these are heated at 90 degrees Celsius and allowed to expand 233 ml. Means if you increase the temperature, this temperature is increased to 90 degrees Celsius. Then volume is expanded from 150 ml to 233 ml. What is the resulting pressure? So he is asking to calculate P2. So we have V1 and V2. P1 is 1 atmosphere. So P2 we have to calculate, and T1 is 273 Kelvin, that is at STP conditions. So here 90 degrees Celsius is given. Now we have to convert this degree Celsius into Kelvins. So 90 plus 273. Then it will be 363 Kelvin. Okay, this is T2. Now substitute these values in P1 V1 by T1 equal to P2 V2 by T2 formula, right? See. So our formula is P1 V1 by T1 equal to P2 V2 by T2, right? So what is the P1 value? 1 atmosphere. And what is the V1? 150 ml by what is the T1? 273, which is equal to what is the P2 value? We have to find. And what is V2 given? 233 ml by what is the T2? 363 Kelvin. What is the T2? 363 Kelvin. So just if you calculate this, I want P2, then 150 into 363 by 233 into 273. If you do the calculation this, then you will get the P2 means atmosphere. The resultant pressure at these conditions we will get by calculating this. Okay, like this we have to do the application part, right? Comes to the next one, Emonton's law. See, Boyle's law, Charles' law and combined gas laws. Next one is Emonton's law. What is this Emonton's law? See, in Boyle's law we kept temperature is constant at a given temperature like we have taken. At Charles' law we kept pressure constant, means at a given pressure volume is directly proportional to the temperature. In combined gas laws we have taken at a given temperature, pressure and condition. Based on those two laws we have taken, right? See, this is Emonton's law. This law correlates with the pressure and temperature of given amount of a gas at constant volume. What is this? At constant volume. So, in Emonton's law we are keeping volume is constant, right? So, according to this one, at constant volume pressure is directly proportional to temperature. You take, suppose if you take some gas, right, you started heating, you have increased the temperature. You in a closed vessel you take some amount of the gas, any gas, then you started increasing the temperature, heating, then temperature is increasing. Then what happens to the inside the gas? The molecules will start vibrating. Temperature is directly proportional to average kinetic energy of the molecules. Average kinetic energy is nothing but movement. The molecules will move very faster, right? So, why they are moving? When they are moving very faster, the pressure inside the container will be increases. So, at constant volume, pressure is directly proportional to temperature. If you increase the temperature, pressure inside the container also increases, right? So, P proportional to T. This one, proportionality constant, if we write P by T equal to constant K. So, obviously when you are taking for the two different gases, then it will be P1 by T1, or at two different conditions also we can take. Then P1 by T1 equal to P2 by T2. This is called Emonton's law. Okay, see. So, let us do one problem based on this Emonton's law, then you will understand it. Emonton's law, at constant volume or for the given volume, pressure is directly proportional to the temperature. Then the formula is P1 by T1 equal to P2 by T2, right? Now, let us see this application. A cylinder of a gas has a pressure of 8 atmospheres at 27 degrees Celsius. Pressure is given, temperature also given. At what temperature on degrees Celsius will it reach a pressure of 2 atmospheres? So, he is asking the relation between pressure and temperature. He didn't talk anything about the volume, means volume is constant. So, we have a law that is at constant volume, pressure is directly proportional to temperature. Then P1 by T1 equal to P2 by T2. Let's see what is the data given. The data is given first. Pressure is given how much? 8 atmospheres. Then temperature T1 is given 27 degrees Celsius. This one you have to convert into kelvins, then 273 Kelvin, total 300 kelvins. At what temperature? Again that temperature is asking in degrees Celsius. So, after getting the answer we have to convert again that Kelvin into degrees Celsius. So, pressure is 2 atmospheres. So, P2 is 2 atmospheres. So, what is T2 in degrees Celsius? That is our question. So, apply in this P1 we know P2, T1, T2, right? So, what is P1? 8 by what is T1? 300, which is equal to P2, 2 atmospheres is given, T2 we have to calculate. Therefore, take T2 equal to 2 into 300 by 8. 2 4s are 8. In 4 table 300. 4 7s are 28. 4 5s are 20. So T2 is 75. It is in kelvins actually. Right? This one we have to convert into degrees Celsius. Okay. So generally what we are doing, while converting from degrees Celsius to Kelvin, we are adding 273. Now we have to convert 75 Kelvin into degrees Celsius. So we have to subtract 273 kelvins from this, then we will get the degrees Celsius. So 75 minus 273 kelvins, then obviously we will get 198 minus 75 minus 273 Kelvin, then you will get minus 198 degrees Celsius. That is the temperature. At that temperature, pressure is 2 atmospheres. A cylinder of a gas, a pressure of 8 atmospheres at 27 degrees Celsius. At what temperature will it reach a pressure of 2 atmospheres? To get it to 2 atmospheres, temperature is decreased, right? Sorry, pressure is decreased from 8 atmospheres to 2 atmospheres. So obviously the temperature also should decrease. It is decreased from 27 degrees Celsius to minus 198 degrees Celsius. Okay. So like this we have to do the problem based on Emonton's law. Right. Come to the next one now. This is Gay-Lussac's law. What is meant by the Gay-Lussac's law of combining volumes? According to Gay-Lussac, what he want to explain in this, for the given conditions of temperature and pressure, to form one compound, always the reactants will react and form the product in a particular volume, in a particular ratio. Suppose see here, H2 plus Cl2 gives rise to 2HCl. So always H2 plus Cl2 gives 2HCl. Always one volume of hydrogen combines with one volume of chlorine, produces 2 volumes of HCl. There is no change in that. While forming water also, H2 plus O2 gives rise to H2O. Actually it is not balanced. In stoichiometry already we discussed that always we have to deal with the balanced chemical equations. To balance this equation, 2H2 plus O2 gives rise to 2H2O. Now it is a balanced equation. So according to the Gay-Lussac's, always it is when the pressure and temperature conditions are kept constant, 2 volumes of hydrogen react with 1 volume of oxygen to produces 2 volumes of H2O. So the ratio of hydrogen, oxygen and H2O will be always 2:1:2 for water molecule, and for HCl always the ratio will be 1 volume of H2, 1 volume of Cl2 gives 2 volumes of HCl. This 1:1:2 ratio is always constant, right? So that is the Gay-Lussac's law. Whenever gases react automatically, the volume of gases, reactants and products bear a simple ratio to form the product, right? Sorry, so this is called Gay-Lussac's law, right? Now come to the next one, Avogadro's law. This law explains at constant temperature and pressure, volume of any gas is always directly proportional to the number of moles or number of molecules. See, under similar conditions of temperature and pressure, similar conditions of temperature and pressure, equal volumes of all gases contains equal number of molecules or moles. See, at room temperature you take just 10 ml of a ammonium gas, right? In the 10 ml of ammonium gas, you have 20 NH3 molecules. Okay. So, whenever and wherever you keep constant the pressure and temperature, there is no change in the number of molecules for that volume. Always 10 ml of NH3 gas contains 20 NH3 molecules only, there is no change in that. That is called Avogadro's law. Volume of a gas at equal volumes, always the same volume, 10 ml or 20 ml or 30 ml, if you take, the same number of gas molecules will be present in that, either 20 or 30, whatever it is. Okay, the number of moles or number of molecules will be same for the particular volume of the gases at constant temperature and pressure. This is called Avogadro's law. This one we represent with V proportional to N. If you take small n, that is number of moles, capital N indicates the number of molecules. This one already we learnt in mole concept, right? So, V1 by V2 equal to N1 by N2 or capital N1 by capital N2. Isn't it? V proportional to N. Then V by N equal to constant. Then V1 by N1 equal to V2 by N2. V1 by N1 equal to V2 by N2. This is called Avogadro's law. While we are talking about the number of moles or number of molecules, already we know the formula for number of moles, that is given weight by gram molecular weight. Given weight by gram molecular weight is formula for number of moles. If you take for number of molecules, in case if you take for number of molecules, then it will be into Avogadro number, means 6.023 into 10 to the power of 23, right? So, this is the Avogadro's law, right? Okay. Now, come to the next one, very important one is ideal gas equation. Next one is ideal gas equation. This ideal gas equation we can say as a combined gas laws. Here, we will take three gas laws. One is Boyle's law, Charles' law and Avogadro's law, right? So, at constant temperature and pressure, volume of a given to calculate or anything, here Boyle's law V proportional to 1 by P. And Charles' law V proportional to T, and Avogadro's law is V proportional to N. From the above three relations, means see here, volume is directly proportional to 1 by P, volume is directly proportional to T, volume is directly proportional to N. So, all are volume, right? So, I will write here volume is directly proportional to, these two are directly proportional and P is inversely proportional. So, simply I will write NT by P, V proportional to NT by P. I will remove here this proportionality constant and I will introduce a ideal gas constant, ideal gas constant R. Then V equal to R N, capital N means number of molecules, small n if you take, that is number of moles, by T into P. So, simply I will write it as PV equal to N R T. Always you try to prefer to take small n only, number of moles. So, here P is the pressure, V is volume of the gas, N is number of moles of the gas, and R is universal gas constant, and T is temperature of the given gas. And what is this ideal gas means? First of all, generally see we have some real gases. Real gases does not obey all the gas laws. Suppose if you take one helium or some ammonia gas, either that obeys Boyle's law or Charles' law, that's it. Any one gas, any one law they will be obey. But ideal gas is nothing but the gas which obeys all gas laws is said to be ideal gas. Generally these ideal gases does not exist. Real gases will not obey all the gas laws. Ideal gases will obey all the gas laws. That's why we call that is as ideal person, like ideal gas. right? So this ideal gas equation PV equal to nRT. See, R is a universal gas constant. R has the different values at different units. R value in liter atmosphere per mole Kelvin, it is 0.0821 like. So we have a different units for R. See, suppose if you take R, this is PV equal to nRT. R is the universal gas constant. This R value will be 8.314 in kilojoules per Kelvin mole per mole Kelvin. Suppose if you take liter atmosphere, R value will be 0.0821 into 0.0821 liter atmosphere per mole and Kelvin. Suppose if you take in calories, R value will be 1.987 something, so we will take round figure it as 2 if you take in calories per mole Kelvin, right? So whenever you are taking, suppose if you want to take in joules, you have to take 8.314 into 10 to the power of 3 minus kilojoules na 3. So joules per mole Kelvin. So R value depends upon the remaining one. If you take pressure is in atmospheres, temperature is in Kelvin, volume is in liters, then you have to take 0.0821 liter atmosphere value. Suppose if you are taking P is in some Newton meter square like that, if you are taking that, then these units will be changed, but no need to worry. In the brackets they will give what is the R value in which units we have to take, like generally we will take 8.314 in joules like we will take, otherwise we will take 0.0821 while doing the problems, right? Okay. Let us see one problem on ideal gas equation. See, how many grams of nitrogen gas will exert a pressure of 760 mm of Hg, or 760 mm of Hg in a 11.2 liter container at 273 Kelvin. So the given problem, how many grams of nitrogen? So he is asking to calculate as weight. Weight is question mark. To exert the pressure of, so pressure is given, how much is given? 760 mm of Hg, right? And in a liter means volume is given, how much is given? 11.2 liters is given. Of liter container at 273 Kelvin. So what is given? Temperature is also given, 273 Kelvin. So it is in pressure is in mm of Hg is given. So we need to find R value. If you take liters is given volume, so you can take liter atmosphere. So 0.0821 liter atmosphere per mole Kelvin, right? So first of all we should convert this 760 mm of Hg into atmospheres, right? So how? Divide with 760 mm of Hg, then you will get the into atmosphere. So always how to convert the mm of Hg's into, suppose 360 mm of Hg like they given, they are asking to convert in atmosphere. So you have to divide with 760 mm of Hg, then it will convert into 1 atmosphere. So I want to convert this one. Anyway, if I divide with 760, then it will be 1 atmosphere, right? So substitute these values in the given ideal gas equation. See, that is PV equal to nRT, but N means number of moles. He is asking to calculate weight. So what is the formula for number of moles? Equal to molecular weight. So PV equal to nRT, in that P is 1 atmosphere, volume is 11.2 liters, equal to weight by molecular weight by R into T. R means 1 into 11.2 by R means 0.0821 into temperature is 273 Kelvin, right, equal to weight we have to find, but molecular weight of nitrogen gas, nitrogen is N2. So for 1 nitrogen it is 14, 2 nitrogens it is 28. If you observe clearly, always if you calculate 0.0821 into 273, that calculation will be 22.4. So I will write here 11.2 by 22.4 into 28 equal to weight, right. So 2 times 2 14s. So weight of nitrogen will be 14 grams, right. Weight of nitrogen is 14 grams. So this is the way we have to do the problem, right. Okay, thank you so much. This is for till the ideal gas equation we have completed. So in our next class we will go to the next class, Dalton's law of partial pressure, and the remaining gas laws we can read in the next video. Okay, thank you so much.